Okay. Okay, so as said, welcome to everyone. My name's Liam Walton from Matrix Technology Solutions. For those of you who are unaware of Matrix, we're a company based in the United Kingdom. We've been developing products for education, training, and industry for 28 years now, since 1993. In fact, it was just our 28th anniversary last week. We are a team of engineers and manufacturers. So the products that we show you today are manufactured here in our factory in the United Kingdom. And we work in Sri Lanka, as I just explained, with DB Gangoda. We work in over 50 countries worldwide across all continents to supply our solutions, which are designed to allow students to learn various disciplines of technical and higher education, focused around science, engineering, and technology. Our website, if you just give me a moment. Is here. So it's matrixtsl.com is our website. Here you'll find all sorts of information about the products and solutions that we have for various disciplines. So we break the products down into discipline areas, including Industry 4.0, which is one of the things we're going to talk about today, CNC machining, microcontroller systems, electrical machines, another product we'll talk about today, automotive, and so on. And then we have various products which are all developed, designed, and manufactured by us, which are outlined here. Okay. One of the key and important things about Matrix is that we write curriculum, and the curriculum that we write is all available on our website, completely free of charge. You don't need to log in to access any of the curriculum. If you just go to the Learning Center, as we call it, which is here, you'll find all of the courses presented to you so that you can see these before you make any purchasing decisions on our products. So that's a really useful thing to have available to you. So that's a very brief introduction to our company. I think what we'll do now is we'll move into talking specifically about the products. At any time, if anyone has any questions to ask, please do not hesitate to unmute yourself. Everyone is at the moment muted, but you can unmute yourself very easily, or you can pop your question into the chat. If I don't answer it immediately, I will check at the end and make sure that everything has been addressed. So I'm going to just show you a few of our products today to give you an introduction to us and what we do. We will talk about, first of all, our smart factory system for Industry 4.0, and alongside that, the robot arm production cell. And then we'll go on and talk about our electrical machine system. Hopefully, this part of the webinar will last between 20 and 30 minutes. And then we'll also do some demonstration on the products, and there'll be an opportunity for you to ask any questions. I know it's a Saturday afternoon, so I don't want to keep everyone for too long. But yeah, we'll see how this goes. All right. So just bear with me, and I'm just going to share a presentation with you. Okay, hopefully you can see this presentation. If anyone has any issues, just let me know, but hopefully you can see that now. This is our smart factory. This is a new product that we've only introduced this year. The smart factory is designed for students to learn about Industry 4.0 concepts, but essentially learning using a student-friendly piece of equipment that's both affordable and rugged. This system is designed to work alongside a separate product that we've had in existence for a while, which is the robot arm production cell. And we'll talk a little more about that as we go through the presentation. Okay, I'm just going to briefly change the presentation view for you so it's easier for you to see. Just give me a moment. Okay. There, that should be better. Let me know if it's not. So we have video on our website. I briefly showed before, for those who were here, our YouTube. You can link to the YouTube directly from the main website homepage, and I'll make sure that I send you video to the products that we discussed today. So video is available. Just to give you a brief product description of the Smart Factory, this allows students to get experience of a number of processes and technologies that are commonly used in manufacturing and modern day Industry 4.0 principles. This includes conveyor systems, sensing systems, pneumatic pick and place technology, DC motor drives, and stepper motor drives. So we break this system into various parts, and I'll explain as we go through this how we expect students to learn using the piece of equipment. Here is a list of the various learning objectives that students acquire from using the Matrix Industry 4.0 Smart Factory. They learn about stepper motor drives, limit switches, which are present on the gantry system, rotational to linear movement using stepper motors, different types of valve, 3-2 and 5-2 electro-pneumatics, vacuum suction systems, positional control, DC motor control using PWM, rotational to linear movement with DC drives, different types of sensors. So now we're moving on to the learning objectives that are linked to the conveyor system. Sensors, inductive and capacitive, light gates, positional control with DC motors using timing, rejection mechanisms, and then moving on to the robot arm production cell, workspace and planning, robot arm movement, and then control, development of programs, and pendant and G-code programming. So there's a lot of learning objectives that can be acquired using this system. Here we have a brief overview of the system. This system is, we'll show it to you shortly when I switch the camera, but this is designed to be desktop. Like much of the Matrix equipment, it's not designed to take up too much room in the lab, which is a great thing because it means that your students can get hands-on much quicker. The size and the affordability of the equipment that we offer means that you can generally afford to acquire more than just one system. You can then use the systems in tandem working together, but also your students can get hands-on much quicker. And as we all know in engineering disciplines, hands-on learning is super important. The Smart Factory system, as we previously explained, includes a gantry system, which is labeled number 1, which comes at the back of the system, a plunger suction device, which is connected to the gantry, a conveyor system, point 3, which is fitted with sensors just above the number 3 there on the label, electro-pneumatic components, which are connected to a compressor, a small desktop compressor that we offer, sorting bins. Number 5 are the sorting bins from the conveyor and the rejection mechanisms. And then we have the ability to input a robot arm location in number 6 with sorting bins for the robot arm at point 7. So the Smart Factory is the first piece of the jigsaw. The second piece that people need to have an understanding of is PLC programming. So we have 2 options here, and one of these options must be taken by the user. So there are 2 options for programming and controlling the Smart Factory. The first option is designed for easier use and control because it's using what we call an educational PLC. This is called the MIAC. This is our own development. A MIAC is a straightforward educational PLC approach to controlling the system. So we use two of these, which are connected, one to control the gantry system and the other to control the conveyor system. Inside here, we have a powerful DSPIC microcontroller device, and then it's encased in a rugged case, which has the 4mm connectors which connect up to the smart factory devices. Users can then develop programs by following the curriculum in order to control the smart factory setup that they have chosen. To use this system, users will need to also invest in our Flowcode control software. Flowcode is a fantastic development that we develop here at Matrix. It's a really powerful way to program microcontroller embedded devices. So devices like the Mayak, Arduinos, the robot arm production cell that we'll talk about shortly are all programmed using this environment. You can use this environment to coordinate pendant and G-code programming, but mainly for learning C code using a graphical environment. So there's full simulation based in this system, and it's really good and really effective for programming, particularly if you opt for the Mayak option. The second option for control of the smart factory system is our Siemens smart factory add-on, which is the AU3686. You can see the smart factory Siemens add-on on screen here. So this consists of a powerful S7-1200 Siemens PLC. Connected to this are a number of what we call adapter modules. So we have an adapter module there for power, an adapter module for inputs, and two motor output modules as well. And they connect to the system on a DIN rail, which can then be connected to the side of the smart factory and allow the user to control the system using Siemens technology. Linked to this, Matrix are also a Siemens education partner. Okay, so we have preferential purchasing and good rates on Siemens related products, and our curriculum is written around the Siemens environment. If you opt for the Siemens method, you'll need to also consider control software. So Simatic Step 7 software will be required. That can either be sourced locally through Siemens representation in your country, or we can source that for you through Matrix. Either option is certainly possible. We don't include it with the product because many academic institutions already have the software in their university or college, so we don't include it as a standard, but we can acquire it very easily if you need it. Okay, just a question that came through, which was about how accurate these systems imitate the actual system which is available in industry. I guess really that's down to how you choose to program the system. If you're programming the system using Mayaks, then you're opting for what I would consider to be a more educational method of learning. And so this is probably more for an introductory level. If you're using this system for introductory Industry 4.0 teaching and teaching about sensing and rejection mechanisms, robotics and things like this, then you are imitating less an industrial system. If you opt for the Siemens methodology, then you are more aligned to imitating what would be present in industry. All of the components that we use on the system, the sensors, the pneumatic components are all industry standard. So yeah, it's dependent on which route you go through, but yes, certainly we are imitating an industry level system. Okay, robot arm then, this is optional, but 90% of customers and users will opt for including the robot arm production cell in the system. This is a standalone product. I have a separate presentation which I'm not going to go into detail on today, but I will share with you when I send you the follow-up to this. The robot arm production cell is based on what we know as all-code technology. It's a development by our own engineers here at Matrix. All code technology means that essentially this robot arm runs on a microchip device, and onto that device, we have an API, an application programming interface. The API means that you can program that robot arm using multiple different languages. So you can use something as basic as Scratch, which is used widely in the US and the UK and beyond in high schools and even below that in middle and primary schools. Okay. You can use something at the next level like Python, okay, to program this. You can use at the next level an environment like Flowcode, which is our own proprietary software to simulate and code and program the robot arm production cell. Or at the highest level, you can use packages such as MATLAB, LabVIEW, and so on by following the API library to program the robot arm production cell. So it's a really powerful and interesting piece of technology and product that we've had on the market now for a long while, and we have many users throughout the world. This robot arm production cell, the one that we sell as a standalone product, can be added to the smart factory system. And this allows users to pick and place, color sense, and remote control the whole system in order to develop a system that doesn't need any human interaction and involvement. It can be a full circulated system. Okay, so most of our customers do opt to include this in their option. Okay. So options for purchase and what needs to be considered by the user. First of all, you need to obviously have the smart factory, which is known as the AU4956. Alongside that, I briefly mentioned the desktop compressor. That's optional as a separate item because many labs already have built-in and compressed air, but it's there as an option. It's affordable, it's small, and it's running on just 24 volts. Incidentally, something else I should mention is that this is low voltage equipment. Everything here is running at 24 or 12 volts. So there's no safety concerns for you or your students when using the equipment that we offer. And that's true across much of the Matrix equipment as well. Secondly, the user needs to decide on whether they are opting for control option 1 or control option 2. I have got examples of customers who do opt for both options because they want to introduce students using what I would call control option 2, the MIAC, the AU4417 with Flowcode software, and then move on to control option 1, which is the Siemens control add-on, AU3686 with the Siemens software. But the option is there for you as a user. And then finally, the optional robot arm production cell. So I did mention at the beginning about how we approach the curriculum manuals, the worksheets, and this type of thing for our products. For those of you who weren't here just at the very beginning, I did briefly show the Matrix website, matrixtsl.com. If you go there and head to the Learning Center, which is very easily navigated from the homepage, you'll find all of the curriculum relating to all Matrix products that is listed here. And this is because we offer all of our curriculum completely free of charge. Okay, we do this because we want users to see what the students are going to learn before they make any purchasing decisions on the equipment that we provide. Okay, and it's very well put together. There are many tens, if not hundreds of different curriculums, hundreds of worksheets relating to all of the products that we offer. The curriculum for the Smart Factory is split into sections. So we split this into 4 different sections. First section is the conveyor worksheets, then the gantry worksheets, then the robotic arm worksheets, and then a full Smart Factory worksheet, set of worksheets. And the reason we do it like this is because it then allows you to have a different approach to how you want to teach. For example, you could say that you're going to have 3 of these systems, just as an example, and the students work in small groups of 3 or 4, and they go through the conveyor worksheets, then the gantry worksheets, then the robotic arm worksheets, and then the complete Smart Factory system worksheets. Alternatively, if you just have one of these systems, you can have some students working on the conveyor, some on the gantry, some on the robotic arm, and then they come together to work on the smart factory system. The approach is completely up to you. Relating to this then, that kind of concludes a little bit the presentation on the smart factory. But relating to this, we've got a whole host of options and availability of products for Industry 4.0. Industry 4.0 is not just about learning smart factories. Students need to learn about communications protocols, sensors and robotics, microcontroller systems and PLCs in order to be fundamentally ready for Industry 4.0 learning. And so all of these products that we have here, including our electrical machines and process control teaching equipment, is designed for the purpose of learning about Industry 4.0. On here, you will find, when I send you this presentation, there is a brochure linked so that you can take a look at the individual products in the Industry 4.0 range, including the smart factory. Okay. Good. Okay. So what I plan on doing now is just stopping this share. Great. Okay. I'm going to switch the camera. As I said earlier, if anyone has any questions at any time, do not hesitate to give us a shout. Okay. So hopefully, I've just switched the camera here. Hopefully you can see the smart factory system that I have set up next to me here. I'm just going to head around here just a second. I'm going to turn on the conveyor, and then I'm going to turn on the gantry system. I'm going to explain what we should see. We should see the gantry system, which is at the back here, collecting from the workpiece holder the counters. We have different types of counters on here today. So we have steel counters, we have plastic counters, and they're going to be collected by the suction device, dropped onto the conveyor system. They're going to be, depending on their on what type of material they are, they'll be put into the rejection bins. And then we'll see if we can get one of the plastic counters to be collected by the robot arm production cell from the end of the conveyor system here, move to the color sensor and into the bins. So just give me one moment and you'll see this working shortly. Because of the noise that comes from the conveyor system, I don't want to talk over it. It's not very noisy at all, but it's just, it might, I wanted to explain what's happening kind of before I set it going, just in case you can't hear me so well when I'm over by the system. So just give me a moment and you'll see this working very shortly. I'm just going to action the robot arm production cell. Okay. So that's collected the workpiece from the end of the conveyor system. Here we have a color sensor, and we should go into this bin here. Yeah, okay. Now, what we can also do is we can program this system so that this will now go back to its home point, but we can allow for collection from the conveyor system onto a second smart factory device at the side and build a whole stream of these. I'll just unplug that so it's doesn't continue. The alternative is that we can take the plastic counters from the end of the conveyor system and we can move them into the workpiece holders here at the back and do a continuous system like that. So there are various options available. Really, it's up to the user and the students to program the system and set it up in a way that suits them, in the way that they want it to be. So yeah, the kind of options are there for flexibility as well. Okay. Hopefully that will just stay there now. Okay, so I'll just switch over camera again. Now I'm back next to the desk. I just had a loose connection there, which is why I had to plug it back in again. I think that had come loose from when I moved over there. I tripped over a wire. Okay, so just getting some questions coming through on the system, on the chat here, which I just want to address before we move on to another product and briefly talk about that. Whether there are provisions to interface and integrate SCADA and MES system modules to product for a complete Industry 4 experience. Yeah, of course, at this point, we have really only introduced this product earlier this year. And the beginning point for this was to allow for a method for studying using industrial or educational PLCs on smart sensors, robotic systems. And SCADA and MES system modules are something that we're looking into at the moment. And I'm sure that this product will develop further over the coming months and the coming years as we develop further additional versions of this as well, to make this something that might be more linked to industry in the future. So yeah, certainly that's something that we might be doing at the moment. It's not possible to introduce and link those. There is certainly possibility to use the system not only with the Siemens and MIAC options that we offer, but if you have preferential PLC type systems and SCADA systems that you want to control the smart factory with, as long as they meet the requirements which are outlined in the curriculum, then you don't have to opt for our control options on that. So yeah, you kind of can do that a little bit, but we don't offer it. It's more down to yourselves. S7 PLCs working with Wink. Yes, that's correct. They do. So yeah, the answer to that is yes. Okay. I'm kind of at this point wanting to move on to another product, if that's okay. But we can always come back and ask a question. Sorry?
There's one more question before the SCADA one.
Which question?
Yeah, how accurate the system imitate the actual system which is available in the industry?
I think he answered that earlier.
Okay. Yeah, it's I did kind of answer that earlier, I guess, because there was a question that came about how closely this links to an industry type system. And just to reiterate that, I think it's kind of dependent on which control option that the customer goes for. There are we've presented two control options. One is with a MIAC system, which I've shown you demonstrated here with the smart factory we have in the lab here at Matrix. I would consider that to be more of an educational system, not really mimicking too much what we have in industry, but great for introductory learning, and great for maybe introducing new students to Industry 4.0 to the concept. If you opt for the Siemens system, then you're certainly going into something that's more in an industry context. And then beyond that, there are options, of course, for people to, as I just mentioned towards the end, opt for their own control systems, using their own SCADA environments and things that aren't offered by Matrix. And that would be more linked and more akin to an industrial system. So the kind of levels go up as you decide on your control options. That's kind of how I explained it a little earlier. Okay. Okay. I'll move on then. We can come back to this and ask questions later if anyone has any. I'm just going to, again, share a presentation. So just give me a moment just to get the presentation running. And we will share a screen. In fact, before I share the screen, what we're going to talk about now, I've just one question quickly that came in. The robotic system and programming method is if that's similar to FANUC robots. It is, but obviously not using the industrial environment and language that is used with FANUC robotics. What we do is kind of bring that down to a level where students are using a more affordable system, and they are using something that imitates and mimics the industrial languages. And so this is a 3 degree of freedom robotic arm with a fantastic specification. It's scaled down from a FANUC robot. The programming methods are various. So you can use simple drag and drop graphical programming environments. You can use scripted programming environments. You can use G-code programming environments, which might be more akin and linked to industry. But yes, so the options are there in order for you to use this as a nice introductory build up to the FANUC robotics systems that I see throughout education and indeed industry. So we're going to talk now about the electrical machine system. So electrical machines, this is essentially one of the machines, one of the motors that we offer in our electrical machines range. As you can see here, this is about the size of my hand. It's fairly light. It's our own development. We have 7 or 8 different types of these motors now. This is a shunt motor. You should be able to just see that on the camera there. And these are running, these run at 24 volts, okay? So you connect up a dynamometer to here, which you'll see in the presentation I show shortly. You have a control box, and then you run the system and you control it using our own proprietary software environment, or you connect up to LabVIEW or MATLAB and you teach students about different types of electrical machines. The great benefit here is that we have a smaller system, so there's no need for the huge motors and machines that you see elsewhere. But the results that you get from these smaller 24-volt machines, and I will show you the results documentation that I've got just now, the results you get mimic exactly what you'd get from the bigger 300 watt, 1 kilowatt machines that are available on the market. And this has been really, really popular. Many universities throughout the UK, the US, Canada, and beyond are using this system now for their teaching. We have the shunt machine. This is the DC machine, so much smaller in scale, but again, 24 volts running at 50 watts or up to 100 watts. You have the connections on the end here as well. So those are the machines and how they look. I mentioned then just briefly about the results documentation. Here you'll see we launched this system almost 2 years ago now, and this is an example of the results graphs, speed torque curves that you get from the electrical machine system from Matrix. So you have here on this one, the DC motor, speed torque curve, where we're running at various different frequencies, the RPM running up to 2000, and the torque is designed and shown on here. We have the same documentation for the shunt motor, the series motor, the three-phase machine, the single phase, and the brushless DC. The software also has graphing capabilities for oscilloscopes, so you can see a virtual instrument. There are actually 14 different virtual instruments embedded in the control box for the electrical machine system. And I will send you this document because it's really interesting and really good for you to see and to kind of prove to you that this system is essentially mimicking an industrial system. Okay. Okay. I have a presentation then on this that I just want to briefly go through with you before I take any questions. So this is a revolutionary modern way of safely studying characteristics of different types of machines in a learning environment. It's also controllable over the internet as part of a remote lab, and there's built-in Ethernet connection to the control box. We have 7 different types of machines, 2 advanced add-on options, and 4 separate curriculum workbooks or manuals that come with this system. This is probably over the last couple of years one of our most popular products globally across all markets. So we split the benefits of our system down into 3 areas: practical benefits, which include the support of different learning styles. There's the ability to manually control the motors and machines or control them via PC software in order to take measurements and readings. So you can take them using handheld meters and scopes, or you can take them using the graphical PC software. I mentioned earlier about online connectivity for a remote lab. The machines are small in footprint, portable. You can pack them away at the end of a session. And we supply everything in stackable boxes, so it's easy for you to pack away and store at the end of a session. We have many safety benefits to this system as well. All moving parts are covered as standard, meaning safety operation is present for students using the machines. Everything operates on 24-volt power, AC or DC, which removes any dangers of working with mains power for students, staff, and maintenance technicians within the university. And of course, there are therefore operational benefits. Users can measure voltage, current, and power in DC and AC. Speed torque graphs are easily created, in allowing the user to either automatically or manually record results of experimentation. There are over 60 hours of teaching included across 4 different curriculums, covering engineering from age 16 to 18 and in undergraduate university study as well, including MATLAB. And LabVIEW. We also have 7 different types of motors, including brushless motors and add-ons for locked rotor study and transformer systems. The system works, as you can see on screen here, using the control box, which can either be connected to a PC if you're using the PC software, or it can be used manually. So the user inserts the machine into the dynamometer, wires up the motor or the machine into the system, loads the relevant software program if applicable, and then follows the worksheets available in order to take readings and conduct measurements. Here are the different types of machine and motor in the range. Firstly, you have the dynamometer, which is a long-shafted permanent magnet DC machine, free rotating between bearings mounted in a cradle. One side can be coupled to any of our test machines, and it's covered and it runs at 24 volts, meaning full safety, 4 mil shrouded connectors, everything is taken care of there. I won't go into great detail about each of the machines because I'll send you this presentation, but just to kind of go through them for you. We have the brushless machine. The brushless is really popular because this is small, 24 volt, 52 watt device. The type of machine that you would find in electric vehicles, for example, is really popular amongst this range. We have the DC motor, which I showed to you previously. We have a universal motor, which has high starting torque, can run at high speed, and it's lightweight and compact. We have a single phase machine. We have a shunt machine, which I showed you again just previous. And then we have the three-phase machine as well. Again, a really impressive machine there. No need for three-phase input into your building or your lab. Everything is taken care of using the control box. We then have optional add-ons. I mentioned the transformers add-on, which can be added to the system. And secondly, the locked rotor add-on, which allows students to study at an advanced level about the electrical machine system. So it allows for open and short circuit characteristics of induction motors to be studied and circuit modeling of induction motors as well. The control box is the heart of the whole system. The control box features 14 different instruments embedded within, including meters, voltage meter, current meters, everything that you need there. This is where you take the load for the system as well, in order to add load or take load away from your machine. It's about the size of a laptop. It's small enough to sit comfortably on a desk with the rest of the kit next to a PC. We then have two options for control, either manual operation or PC operation. The PC software is designed by ourselves in order to be, in order to freely be downloaded from our website. Below on the screen here, you can see a range of screenshots showing three-phase control software when integrated with an integrated oscilloscope, showing the gauges which show key values such as current and voltage of the system, and the graphing capabilities as well, which allows for speed torque graphs to easily and quickly be recorded. There's full MATLAB and LabVIEW compatibility. There's even a MATLAB specific manual written for this, and all of that those manuals and curriculum, as usual, are available on our website. So we have 4 available. Just briefly to kind of go through those. Here you have what we call the level 3 one. So this is for age 16 to 18-year-old students and undergraduate year 1 of university. This is the most complete solution curriculum that we've got available, and it goes through various learning objectives outlined on screen there. We then have our manual operation one, which is more for technicians and electrical installation students. We have a specific MATLAB curriculum, and we have advanced electrical machines where we make use of the transformer system and the locked rotor. The system, if you're using it using a manual operation, can be utilized with multimeters and oscilloscopes, which we offer and are on screen and available here. Okay. That concludes the presentation about electrical machines. Does anyone at this stage have any questions about our electrical machines products, the environment, or anything like that? Now is your chance. You can either ask me verbally or just put it into the chat and I can answer it that way. No problem either way. Shula or Ashoka, is there anything that you feel I need to cover that I've missed for the electrical machine specifically?
Not really. I think you have covered everything. I think the only thing I had to mention is if you look at the other competitors' prices, this is fraction of the competition prices. That means you can buy many units of these compared to what you buy from our competitors for 1 unit. That's the only thing I just want to highlight the fact.
Yeah, and the reason for that is because we're running at smaller a lower voltage and smaller size as well of equipment. And so we're able to, even manufacturing here in the UK, offer these products at great prices. So like Chula says, I would certainly consider this system, because we are producing the same results as you get from an industrial system, just on a smaller scale. It's more affordable, so the students can get hands-on. Another thing to mention is that we offer the full complete system, and we offer what we call a core system as well. So the core system allows for study of just 2 different machines, and then other machines can be added if you require them later. So there's 2 options for purchase of the electrical machines products from Matrix. Okay, my plan is that I will send a recording. This will need to upload to our server, and by Monday you'll have a recording. You'll also have links to curriculum, to video, and I will ensure that I send you the presentations, the smart factory, the electrical machines, and the presentation that I have separately about the robot arm production cell. I'll send those to Gangoda, to DB Gangoda, and they will be forwarded on to all attendees and others at the beginning of the week. Okay. Okay, I assume there are no questions, which is fine. I always assume if there are no questions that I've answered them all whilst I've been talking. If anyone has any questions that they want to put to us, they can do so through DB Gangoda. They will likely be able to answer any questions, or they can just be forwarded on to me if you guys don't know the answers. Thank you. Ashoka and Chula, are you happy that we can conclude there for now?
Yes, I think that should be okay.
Good.
Yeah. Liam, thank you very much. It was a very good presentation. I appreciate taking the time off on a Saturday.
No problem.
I know you just came back from holiday, so you probably want to go back to a holiday after this.
Yeah, no, it's no problem at all. If anyone would like any individual one-to-one demonstrations of any of the products, that can be organized any time of the week, within reason. We can set that up. All right.
Thank you, Liam.
Thank you, Liam.
Thanks, everyone. Have a good weekend. Speak to you all soon, and thank you. Bye-bye.
Thank you very much. See you all again.